All right, this is us. We're on Twitter sometimes. Steve's already introduced us, so I just want to take this opportunity to mention the other people that worked with us on this research, because it was quite a big project and quite a huge undertaking. So Daniel Ahn from Google.
It's right there.
Right there. And also Louis Magershak from SOSTA and James Urquhart from SOSTA as well did provide a huge assist on the data science side. So go team.
Yeah, we're the face, and we get to pretend we know what we're talking about. But if you ask us any deep questions, please don't.
We'll just defer you to them.
So I'm going to cover a little bit about the technology first before we get into the results, and Tammy will bring you through sort of what we found out of it. But basically, what we're doing is we partnered up with SOSTA, and we took some of their anonymized RUM data that they get from all of their customers. And we're sort of in a big deep learning, machine learn, all the things. So we said, hey, let's throw the RUM data at machine learning and see what happens, what we get out of it, what does drive bounce rates and conversions. And out of that, we're hoping to be able to figure out, okay, what should we go focus on? What are the important metrics? Hopefully, out of the end, we'll get performance drives bounce and conversions, but we didn't go into it expecting any of that. We were just like, hey, let Skynet go figure out what's going on, and hopefully it'll let us know. The code is all open source. It's all up on GitHub. The slides will also be posted, so you don't have to write down these long URLs right now. And like all things apparently machine learning, it's in Python, unfortunately. So apparently it's a big thing in the machine learning group. So I wanted to just give a little brief background on sort of the technology behind it. Deep learning, neural networks haven't changed in like 20 years, I think. And I only know this because the last time I looked at machine learning was probably about 20 years ago, and I was doing exactly the same thing. And basically, you have a whole lot of inputs, which are on the far left, and those are all the variables you want to throw in. And then each one of those is connected to every neural node under it, and that's sort of the nodes at each layer, and each sort of vertical line is a layer of neural nodes, and each one of those is connected to every other one. And when you get a trained neural network, all that really does is it figures out which one of those lines connecting which other ones are important, and it gives weights to them. And the actual act of training a neural network is really just randomly guessing. It goes, hey, let's start with weights of maybe half on all of these and see how it works out. And we'll try, okay, let's tweak this other one by 0.1 or something. And it keeps throwing crap to the wall until something sticks and you actually get the answer you were trying to get out the back end. And that's why sort of the process of training a neural net takes so long, is it's just guessing a whole lot. And a lot of the evolution over the past 20 years or so has been in making those guessing and those processes better and faster. And that's why we sort of have GPUs and everything else to do this training. It just takes a lot of guessing and math. But when you actually want to run it and you have a trained net at the end, it's really just a quick pass and you're doing a couple of multiplications and you're done. So using a neural net at the end is really fast. It's just the training, you're brute forcing it basically to try and figure out where things work out. And so when we threw all of the inputs in and we had our outputs, which are bounce and conversion, and we ended up with a 99.6% accuracy on our guesses for the trained neural net. So based on the inputs we give it from the RUM data, we could, with a 99.6% accuracy, predict if it was going to bounce or not. The conversion rates were a little lower on the accuracy. I think we hit like 91%, give or take. And we were all really, really excited. And then we went back to the machine learning team and said, okay, so now tell us why. What of the inputs mattered? Let's see what happened with the neural nets. And they're like, oh, I'm sorry, we should have told you before. They're a black box. We can't tell you. You get the inputs, you get the outputs, and that's it. So we went back to the drawing board a little bit. And so less sexy, less deep learning, but still machine learning, something called random forests, which are basically decision trees. Instead of taking all of your inputs and assigning weights and then you get an output, it basically goes through a decision tree of starting out looking at one of your variables, splitting, looking at another one of your variables, splitting until it comes to a decision. And a random forest just takes a whole lot of those decision trees, puts them together, and then gets a rough answer. And the training for that, pretty much the same as for a neural net. It throws random trees until it gets answers that look like your training set. The good point on the random forests, other than being a whole lot faster to train, is you can actually get the weights out and you can see what mattered as far as your input data. So as far as the machine learning in the code, both of these are available. So depending on what you want to do with your data, you can go ahead and run either set. If you just want to be able to predict, go ahead and use the deep learning side of things. If you want to figure out based on your data set, what are the inputs that actually matter, then go ahead and use the random forest bit of the code, and that'll tell you of your inputs which ones impacted the outputs by how much. The vast majority of the code, and I should prefix it, the code is like 200 lines total. So when I say the vast majority, we're talking like 80 lines of code, is preparing the data to actually do the machine learning. And there's a couple of things you need to do. Like all of the machine learning works off of numbers. So if you have strings, let's say the device name, you end up building a histogram where one of your inputs actually being device name was Samsung, yes or no, and that's a 1 or a 0. Device name was iPad, that's a 1 or a 0. So you have to watch out for your string inputs. Individual device names, not too bad. User agent strings, where there's like a billion of them, you don't want, because then you end up having a billion different inputs all saying yes or no for one user agent string. The other thing you have to be really careful of is how balanced your data is. I think we had around a 3% conversion rate across all of the data set. You'd have a really accurate neural net or a machine learning system, 97% accurate if it just always guessed no. It didn't have to look at the data. It would guess no, and it would be accurate 97% of the time. So what you want to do, or what we did at least, is sample it to get as close to a 50-50 mix as you can. It reduces the amount of data you have going in, so more data better is generally the mantra. But that way, at least, you give it a good baseline where it actually makes the decisions based off of the data, not sort of just always guessing wrong. And you also want to be careful. It's possible to overtrain a network, depending on how you set it up, so that it can actually recognize a specific user's session that bounced or converted or did not. And so we hold back a part of the data to go, okay, after we train it, let's test it and run this data against it and see how well it works on data it has never seen before. And that's where we were getting the 99.6% accurate numbers, or the, I guess I didn't say, on the random forest we got 96% accuracy, which is close, not quite as good as the machine learning or the deep learning, but still we were happy with it. And finally, the last thing you need to do is it likes to have data that is generally normally distributed. So you need to do an extra step on your input data. Luckily, Python, being the thing everyone's using for machine learning, has libraries that do all this for you. And it's like 3 lines of code to fit all of your data to a nice normal distribution before you feed it into the machine learning. And again, this is all in the code. The other thing you have to really be careful of is your input data. You want to make sure it's as independent from your outputs as possible. The first time we ran it, it turned out that SSL was the main driver for conversions. And if you think about it, the checkout flow is SSL for everybody. And so, well, yeah, they went through a checkout, so they converted. So yeah, we had to go back. We pulled out SSL. The other thing on the bounce rate, it turned out really long sessions were inversely correlated with bounces. I'm sure that will shock all of you. So you can't just blindly feed all of your data into it. Take a look at it. Sometimes you'll get shocked when you look at your results and you'll go back and go, well, duh, and let's start deleting that and look at just the other inputs. And hopefully not to scare you off too much, but the actual code that does the machine learning, and I really encourage everyone to sort of go out and experiment with this. It's really like 3 lines of code to teach a deep learning network with the frameworks these days. It shouldn't be intimidating at all. And the code that I didn't write, we have a guy at Google that wrote the Keras library. That's one of the models for, or one of the frameworks for doing deep learning on top of TensorFlow. Did all of the code for me, or most of the code for me. So he knew what he was doing, so it's a fairly good template of code to look at if you're going to be doing some of this. And on the random forest, it's one line of code with 20 options or so, but still just one line of code to train the models. And to get out of the random forest, it's just one more line of code to get out of your input data what was the importances. They call the importances basically which one of your features mattered and how much did it matter for your outputs. So really, like once you have the data staged and ready, it's like 2 lines of code to do all of the training and get all of your outputs out. And with that, I'll kick it over to Tammy, who can give you the really interesting stuff.
No pressure. So we did learn some stuff, which is good, because we had already pitched this as a talk before we knew if we were going to learn anything cool or not. And Pat said earlier that whenever we undertook this research, we didn't have any hypotheses. We didn't do that. It was kind of a pure research project where we just took a massive amount of data, threw it into the AI, and just waited to see what would come out with regard to conversions and bounce rate. Having said that, when we went through the process and we're analyzing the data and looking at our findings, I realized that I did have some assumptions, and I would say I give myself like a 55, 60% in terms of my accuracy in guessing what the data would tell me. So that was good. I like to be wrong. It makes life more interesting. So a little bit about what's in our beacon. We use the mPulse beacon to grab our data. The mPulse beacon is built on Boomerang, so it grabs a lot of stuff. This is just some of the stuff that it grabs, but we're talking like dozens and dozens of different attributes. And as you can imagine, whenever you have this much data, it's really exciting. This is like the best part of my job, is the fact that we have all this great user data to play with. If you like studying user experience, I highly recommend getting your hands on lots and lots of data. It's awesome. So we took all of the data that we got from our beacons and put it into the AI and basically learned a bunch of things. These are kind of the attributes that we focused on the most in our findings. But really what I want to focus on are those top 6 and kind of cherry picking what some of those were. The interesting thing is that of all those attributes, you can see that even trickling way off here to the right, there's still some performance impact. So the thing that's really interesting, and I didn't actually even think about this until you pointed out, Pat, is that like actually everything matters. For the purposes of this talk, we're going to focus on the things that matter most, but it was just a really interesting takeaway to see that.
These are the feature importances out of the random forest, and across the bars are basically every one of the input metrics that we had from the beacons.
Exactly. So looking at, these are the top 6 that we highlighted, we thought were really interesting. I won't read them to you. You can read them for yourself. Some people are taking pictures, so I guess I should say something while they're taking pictures. My
sad face is conversion. Like I was hoping the top 6 metrics would all be performance metrics, and I was like, sad face.
So, let me see. We're actually going to take questions at the end. Pat was actually super speedy, so I'll be speedy as well, and hopefully we'll have lots of time for questions. And then we also looked at bounce rate. So same deal, similar graph, a little bit more sharply kind of, gradually flowing down there off to the right. And then bounce rate, interestingly, was a different set of attributes for the most part. A little bit of crossover, but different. And I'm going to go into kind of, again, like I said, cherry pick the ones that we found really interesting, but really we could have dived in a lot of different directions and had a much longer talk. And in fact, we will be.
Yay, performance.
Performance matters. There will be a piece that's going to be published in, I think, with Google, so you can watch for that, and we'll be writing blog posts and diving into this more deeply elsewhere. So our first finding, this is where I personally was wrong about something. So we found that the number of scripts was a predictor of conversions, but not how we expected. So my assumption, which I didn't realize I had until afterwards, was that it seemed logical to me to assume that if a page has more scripts, it's heavier, it's slower, it's more complex, and we're going to have fewer conversions. What we found actually was that throughout so these are looking at median numbers for pages in a session. So for sessions that converted actually had about 48% more scripts than sessions that didn't convert. So we all had to kind of stop for a second and go, whoa, what, why? And we sort of extrapolated that maybe, probably, it's all one word. What it meant was that because people are, those final checkout pages tend to be very heavily scripted, that might be the reason. But it's a question that's kind of worth diving into a little bit more. So we thought that was really interesting.
For the love of all things, please don't go adding random scripts to your page.
Yes.
Just thinking it will convert more.
I mean, yeah, and I guess the takeaway there is, yeah, as Pat said, like, you know, if the number of scripts on your pages indicates that, you know, they convert more, then I would say, okay, well, that's great. Now we know that pages that are heavily scripted convert more. Okay, what can we do to make those scripts more efficient? So that's kind of I would encourage you to think that way, not let's just randomly add more scripts. Now, a follow-up to that one is kind of the opposite, which is that, yes, when you have more scripts on the page, they convert more. However, when you add more layers of complexity onto a page, so more images, just more stuff on the pages, those pages actually converted significantly less. So again, this was one of the ones that felt like a no-brainer, but I'm just kind of pointing it out to say that, yeah, we were right about some things. I wanted to mention that. Another one where our assumptions were correct, not surprisingly in this case, were that sessions that converted had 38% fewer images than sessions that didn't convert. So again, not a big surprise. So this is a prettier graph that shows that. So you can see that the converted pages, the median page in a converted session had about 19 images on it. So that's everything that's like favicons, product images, what have you. So that was really interesting. And you know, there's probably most of the people in the room, and definitely a lot of people who've presented before in this room, you know, can sort of preach the gospel of, you know, optimize your images, you know, make sure that all your images are, you know, lean, the right size, correctly formatted, all that sort of thing. So this just kind of cements that. So nothing super groundbreaking here, but you know, interesting nonetheless. And given the fact that so many retail sites, as Buddy and Billy, when they did their talk this morning, showing what are the top defects of retail sites were, you know, they talked about images. It's still a big problem. So you know, we can keep hammering this point home for quite a while to come. So I thought this was interesting. Moving on to bounce rate. The fact that the greatest indicator of bounce rate was DOM ready time. So takeaway here is, so it's let me see. So you can see that the median DOM ready time for a session that didn't bounce was 4.4 seconds. For sessions that did bounce was 6.8 seconds. That's pretty significant. That's about like 55% difference. And you know, as probably most people in this room know, one of the biggest factors that can delay the DOM being ready is usually your externally hosted scripts, things like that. So a bit of a wake-up call that, you know, we're looking at like top retail sites, still obviously having issues with those kinds of externally hosted scripts slowing down the page.
And in the grand scheme of page load time sucks as a metric, apparently DOM ready isn't that bad of one. And it was, I mean, it struck me as interesting that it actually drove more importance than even like time to first byte or some of the, you don't see any content until these complete. The DOM ready, the point where all of the HTML's parsed, the JavaScript's ready, ended up being a fairly strong driver. Shocked me a little bit.
Totally, and because I mean, I write about performance a lot, and we're always, you know, everybody's trying to find like this unicorn metric, the best metric that demonstrates the impact of performance on user experience, or the impact of performance on conversions, business metrics, and I don't think anybody's ever talked about DOM Ready as being that metric. So this was kind of a huge surprise and really eye-opening. So something to bear in mind when you're looking at your own metrics and what you want to study. And the second greatest indicator was full load time. So here you go. And again, we're looking at 55% slower full load times for the pages that bounced, or for the sessions that bounced versus the sessions that didn't bounce. So the interesting thing here is that if you're following what's being written in the performance community, and I'm totally guilty of having written about it, said it on stages, load time, who cares? We've been stepping away from load time as a meaningful metric for probably a couple of years. I don't know, I'm really bad with times and dates, but and we're trying to find what we think is more meaningful metrics to measure interaction and measure user experience. And load time has sort of started to feel really archaic. It's like it's something that we measured 10 years ago, 5 years ago even, but now it's like we're looking for a sexier, newer metric. However, when it comes to bounce rate, it was our second most important metric, or second greatest indicator. So just a reminder that we don't want to necessarily throw that baby out with the performance bathwater, if you will not mind my terribly horrible analogy, too soon. I think that it's definitely worth kind of keeping in the canon and recognizing that we have things to learn from load time.
Yeah, and this is my sad face because I've been one of the ones pushing away from load time for years. Like even 5 minutes ago when I mentioned it sucks.
So our next finding was really interesting. So this I feel like I was sort of half right and half wrong on this, and I'm sort of speaking for myself because I don't know what all of your assumptions were, Pat, but I kind of thought that the mobile measurements that we would see them kind of higher up the food chain in terms of impact on business. And what was interesting was that we found they weren't. So specifically, there were a few mobile metrics that were out here in this little ghosted area, and they were things like bandwidth, mobile connection type, that sort of thing. And they mattered. I mean, everything mattered, but they seriously didn't matter very much compared to the other attributes that we looked at. And I thought that was really a really interesting indicator. I had to kind of go away and think about what that might mean. And this is just me sort of putting on a thinking cap and extrapolating here. But really, there was a while ago it was like mobile first, and now people are saying mobile only. And now I'm just thinking like it's kind of just same. People, if they're on their handheld device, their tablet, whatever, they're going to your site. They're expecting to convert. There's not really. There are still separate use cases, but I think the lines are blurring a lot more, and this sort of points to that. I don't know.
Yeah, I mean, we had was it a mobile device or not in the data set? We had, was it the OS, iOS, Android, or Windows, the device type? None of those showed up as being important at all, and that shocked me.
Me too.
And even the whole iOS versus Android, maybe the iOS users convert more. No, nothing device specific. It was the web is the web, basically.
And even the bandwidth, like I thought, bandwidth might be like a way of kind of parsing out people who, we know that if you're on a really slow connection, you're probably having a much slower experience. And the fact that wasn't even an indicator, like that people even with terrible bandwidth are still converting at more or less the same rate, or at the very least, we're not seeing any relationship there.
And I guess on the flip side, since DOM Ready and page load were drivers, if they have a crappy connection but they still get a fast experience, PWAs, they still convert, right? Or they don't bounce, right? So it's really about the experience, not so much the end user situation.
Exactly, yeah. And then this one, and this is the one that I think is really, I'm covering my mic. This is the one that I think is really interesting. We're looking at some conventional metrics, like that we are moving towards, or that we've been using for a while, and finding that actually they didn't really mean that much. in the grand scheme of things. And so what those are, so DNS lookup, I mean, probably most of you aren't really using DNS lookup as a significant metric, but because if you're using web page test, you see that dark green bar, if you're looking at your waterfalls, it's on your mind. It's definitely, even if not front of mind, it's like in the middle somewhere. And we found that out of the 93 different attributes, it ranked 79th in terms of impact on conversions and bounce rate. And what was more interesting to me, because this kind of goes back to what we were just saying about load time being a really useless metric, was start render. It's like, wow, what a great idea. Like, we know it's not perfect. It doesn't, it's no guarantee of people actually seeing something on the page, but it's the closest approximation of when that time to interact might be starting to happen, when people might be starting to see meaningful content. And it turned out it was 69th out of 93. So that was a little deflating. So
yeah, maybe a little for you. For me, it was like heart-wrenching. I mean, I don't know how many of you remember like a year ago, or was it 2 years ago, you guys like completely killed progressive JPEGs with your brain study, and I was like, okay, I'm just taking my toys and going home. That's kind of what this felt like, is like I've been focused on render metrics for the past several years, and at least in this data set, to have it show up so low was like,
Pat just threw everything down and just stomped off.
It's like, I don't believe the data.
So
everyone's first reaction.
Yeah, and it's just really interesting, right? Like, and just kind of getting back to the data. I mean, what we ended up looking at, we actually had like over 1 billion beacons worth of data. But then once we sorted things out and kind of narrowed it down, it was something like 1.1 million beacons worth of data. So it's a lot of data, and we like to say data can't lie. So it's definitely food for thought here. So I'm going to pass the mic to you. Talk about some takeaways here, Pat.
Sure, I mean, the main thing, and so we have what the results were when we ran it against like all of SOASTA's customer base, and even that's a wide distribution of content, media, e-commerce, all lumped in together. Really, I just want to try and encourage you, and hopefully haven't scared you off from the machine learning side of things, but it's a really low barrier to entry. And I guess I should probably mention, they need GPUs and all these heavy, like Google just announced the tensor processing unit for machine learning and all of that kind of stuff for doing like video, image recognition, the stuff that has huge input data sets. Even when we were running like the 1.1 million beacons with, I think it expanded out to 1,100 or so input variables. Even doing the deep learning training on my laptop only took like 6 hours. The random forest is like 15 minutes. So this is all really accessible for the kinds of data that we're talking about in the performance community space. Unless you like want to start training it on the videos of your page loading or something like that, then we're talking a whole different thing. And it literally is just a few lines of code and preparing the data. The most important thing really is make sure you're collecting the data. Collect it through RUM. Maybe it wouldn't hurt to also collect your synthetic data and try marrying them together. Experiment with it, run it through the models and see what you get for feature importance. I'd actually really love to hear on a much more focused data set, like if you run a content, like the Vox guys just left. When he comes back, I'll encourage him. If you have like a purely content site, run it against that and see what matters for your bounce rates, for example. If you're doing A/B tests, maybe it's worthwhile to experiment with, okay, were they in the A fork or the B fork of your experiment, and feed that into the data set. And just try it and see how things work out and see if it's valuable. We think it is. The results we got back so far look very promising. They look fairly consistent, even when we've tried throwing a couple of different models at it. And we haven't completely given up on the deep learning yet. There's a bunch of research that's going on right now about getting the importances out of deep learning models and stuff. So we're hoping we can sort of get the best of both worlds out of that as well.
So and I just wanted to add to that, like this isn't, when we first talked about this project, it was almost a year ago, and I had no experience with AI or anything like that, and it sort of all sounds really science fiction-y whenever you're hearing about it for the first time, but it's really not. And I was actually talking, I won't name any names, but I was talking with somebody from a major retail site, and they're actually starting to use this, like use their own version of deep learning, using their own RUM data to do lots of cool stuff, but including like predictive analytics. If you have all of your user data and it's recent, you can predict with a high degree of accuracy, what's going to come next in terms of traffic and other metrics, and you can anticipate problems that you literally couldn't anticipate with any other kind of existing tooling. So there's just some really neat applications for this, and it is starting to be used in the real world. And I definitely encourage, if anyone out there is actually doing this, like on their own organization's site, I would love to hear about it. So please let me know, and maybe be up on stage here.
And so that's the end of the content. Thank you.
Thank you.
Wanted to open up for some questions because hopefully there are some, and hopefully there are some that I can actually answer, or Tammy can answer because I'll punt to her for most of it.
So I know there's a client-side implementation of speed index written in JavaScript. Did you guys happen to add that to the Impulse beacon for this testing? I was curious how relevant that metric was post machine learning.
So the question was, there's a client-side RUM version of the speed index, and was that included in the data set? Has that been added to the SOASTA beacon? No, it wasn't added. And actually, going into this, we expect this really to be sort of the first phase to the experiment. Ultimately, we would have liked to have collected a lot of information, like how many images are above the fold, how many product images how many buttons are there inputs, how are things sized, try and get some more style things about the page. We wanted to sort of take an initial run through the data and see that we get something useful first before we go ahead and start collecting a whole bunch more and be able to use the data set that you guys already had.
Yeah.
Since you already had such a large data set. And you really don't want to add things to like millions of people's pages and collect a whole lot of data if you're not sure it's going somewhere.
Exactly, yeah.
But it'd be really valuable and really interesting to look at. That said, the RUM speed index generally correlates pretty strongly to the first paint, just because it tends to be first paint plus when a couple of the images render in. And given how low the start render ended up out in the results, I wouldn't hold my breath, as disappointing as it would be for me.
Okay.
So kick it over here and then I'll...
So it would be interesting to see if you went back to the modeling and just restricted to the top 6 and asked the question again, because it would tell you how much loss is in performance of the model when you just delete everything else. That's interesting for me to know.
Yeah, so the question was, it would be interesting if we went back to the model, and once we knew we had these top 6 that were fairly important, just delete everything else and rerun the model with just those top 6 and see what the loss rate was and how accurate the predictions were.
Because it will tell you whether everything is truly important, or how much, what's the gap.
Right.
The second thing is that if there are multiple correlated input features in the measurement side, some of them will float up, some of them will go down. It's not necessarily, the group is not going to be distributed equally. You need to be careful about that. Right? In the models that you're using, if there is a group that moves together, like 5 genes cause a disease, one of those genes shows up doesn't mean it's important.
Yeah, so the point was multiple of the input variables could be correlated, and just because one goes up high doesn't necessarily mean that the others aren't, or they may float together. And that actually ended up being, so one of the experiments I was trying to do when I was trying to get the importances out and see what the distribution looked like from the deep learning, is we would take the model and then we'd try varying one of the inputs to see how much it actually changed the output. But then we thought we had results that looked interesting, but then we sort of second guessed ourselves, because you end up with cases where you're feeding the model like a DNS time that took longer than the time to first byte, which isn't possible in reality. And we didn't feel terribly good that the accuracy of our predictions would be right if we were giving it technically invalid data.
There are other types of models, but
Okay.
so the third one is how balanced is the mobile versus desktop data in your data, because the effect that you saw about mobile parameters can be explained if it's not balanced.
Yeah, so the question was the balance of mobile and desktop data, and it was actually 50-50 on the data set for that as well. So we had a fairly good balance. We actually had the data picked out. Come to you in a second, Eric. There was someone up here who had a question.
Yeah, so an online media site versus an online retailer might quantify a conversion differently. Was this specific to online retailers?
Yes.
Was it just one retailer, and was it specific to the checkout? Was that the checkout? Does the checkout quantify the conversion?
It was specific to retail, so we filtered out everything else. And yeah, so it was like classic conversion is checkout. Yeah.
How
So-
many giving?
That's a good question.
It was all of
All
your
the ones,
customer base.
all the ones we have that have given us permission to use anonymized data. So the question, sorry, was what were we focusing on retail, and what were we defining as a conversion, and what retailers, how many retailers were we including in the study?
So, Eric?
Sure. One of the things that he brought up was maybe hidden factors that allowed for correlation across multiples of these different parameters. I'm wondering, did you have a criteria for what site was being viewed, or what kind of page type was being viewed? Because you might find that one site that has high conversion had really good time.
So the question was, did we have a way to adjust for, or did we factor in which site was being loaded in case retailer A had a really high conversion rate but also had high performance, and that would have caused performance to be more important as far as the metrics go? Sorry, I can't remember what I was going to say about that. We actually had input, and did we factor in which pages? So the input data was actually for an entire session, so it wasn't individual pages, and we pulled out average, median, max for each one of the metrics. So we had an entire session all in one data entry, so individual pages wouldn't have driven anything. We also had the anonymized site as part of, like, the identifier for the anonymized domain as part of the input data. It didn't end up factoring as an important factor. But yeah, hopefully that's, when you're looking at your own content, I guess with a site as big as yours, maybe you'll still have different areas or different regions or stuff where some of that may matter. And that's another thing, is by region, we had countries and IPs and all that kind of stuff, and none of that seemed to impact. But be interesting. Really looking forward to this as being sort of the kicking, the starting block that a lot of people sort of build off of and do a lot more work in this space. We'll go over to this side of the room for.
I think you answered the first part of my question. So you said that, like, pertaining to image counts, so that was images viewed across the entire user session, correct?
It was images per page across an entire
That was the
user session.
median, right?
Yeah, yeah.
So that was the median number of images per page.
Okay, so my follow-up to that is, do you think that one of the potential reasons that the lower image count correlated with higher conversion would be because the user is staying off of the high image pages, like a category page or a front page, which typically have a lot, and instead, they know what products they want to see, so they're going to the very low image pages, for their conversion.
It could very well be. I mean, it's just guesswork, but it could be that those people are coming straight from search. They're going to a product page. They're converting as opposed to going through, they're coming straight from Google search and going right to the product page, as opposed to maybe coming in through a category page and then, or using like insight search, all those things that are like much more image heavy. So
It's
that's
also
my theory.
possible if it's a really long checkout flow, for example, and you started out on a product page and you went to a credit card page and something else, and you had a lot of pages with no images on them, that the median ended up being closer to 0, right? So there's a whole lot of things that where you sort of have to, once you see the results, it's like, well, I wonder, maybe let me look at the data and maybe feed it in a different way, like we did with the SSL stuff.
And that's, and
Well, is that something then that you mentioned that you're all planning to continue digging into this data? Are some of those avenues, areas where you're going to dig and hopefully report on?
yeah, that would be great. And this is where, I mean, we aggregated data from a lot of different sites, but if, say a retailer, a media site, or somebody is looking at their own site, they're going to be able to like actually go and do in-page diagnostics and actually really answer those questions. Some questions are just unanswerable with aggregated data.
You want to go?
How many
No one
questions do we
over
have
on
time
this
for?
side that has a question? I just want to balance it out. We'll go the hand up here.
There are some parameters that could impact also the result that obviously you cannot capture, like the quality of the images, and even more important, say the prices of the item. It could be that the pages, that the sales pages, right, are built very differently, yet they have higher conversion rate because the prices are good, right? So how much do you think what you don't know may actually impact the result?
So the question was, how much do we think what we don't know might impact the results? And it's entirely possible, and it's also entirely possible there's something hidden in a relationship that ended up driving the results that isn't what we expected. But the fact that we got 99.6% accuracy on the deep model and we got 96% accuracy on the random forest generally means there's enough information in the input data to guarantee your prediction, and there's not like another variable that wasn't measured. Now, it's certainly possible that another variable that wasn't measured might drive the average cart size or something like that as well, or some other business metric. But for the two that we were looking at, given the high accuracy, especially on the bounce more so than the conversion, yeah, we've got 3 minutes. What are you getting on, isn't it? 1:55. Oh, okay, so we went 2 minutes over.
Oops.
All right, so we'll be around for the whole conference. Feel free to grab us one-on-one. We're happy to talk to anyone about it. Mostly really interested in seeing what you guys do sort of with the next step in the research, especially if you apply some of it to your own sites.